Hey everybody, this is Mr. Schultz here with you, and today we're going to be looking at a concept called compound inequalities. So last couple of days we've looked at just kind of normal inequalities, just basically drawing a circle at some point and then creating the line. Today we're going to look at what happens if you have multiples of those that all need to be true. So let's take a look at this here. We're going to start with this first one. This is in step 2 of the Google Classroom. Be sure that you are following along, taking notes. Don't just passively watch these things because you're going to get way less out of it. So make sure that you are following along, pausing the video, maybe watching it at half speed, different things, a lot like that. So let's take a look at our first one here with word problems. When fishing on Lake Mille, any walleye smaller than 18 inches must be released immediately. So I drew the graph of that. So 18 inches, it could be 18 inches, but smaller than that. So it's going to be an open circle with the arrow pointing that way. When fishing on Lake Mille, any walleye larger than 20 inches must be released immediately. So I'll just go over to 20, and if it's larger, it needs to be bigger than 20. So I'm just going to draw my arrow like that. Now it says this, create one graph that show all the fish that need to be released. Well, if it needs to be released, it needs to be smaller than 18, but it also can't be bigger than 20. So this is our compound inequality. There's two things that need to be met to make this true. So this is what we call an OR statement. It needs to be, X needs to be less than 18, or X needs to be greater than 20. So this is our first compound inequality. I've got these two things, one or the other, which is why I use the word or. Let's see the next one over here. It says this, water is in a liquid state when the temperature is above 32 degrees. So I'm just going to go down here and roughly do 32, maybe somewhere right around here, real close. And it's going to be when it's above 32. So not 32, but above it. It says, the next one says water is in a liquid state when the temperature is below 212. So I'm just going to go out to 212 and again, say that when it's below. And guess what? We're going to create one graph again. So we're just going to go and put those two things together. And now let's take a quick look at this. Notice that these two arrows are actually going to combine. They're going to hit each other. So let's just let them do that. So what this is what's called an AND compound inequality. X has to be greater than 32, but it also has to be less than 212. Both of these conditions need to be true. Because if I have 230, well, 230 is greater than 32, but water would not be in a liquid state. It would actually be in a vapor. So it needs to be between 32 and 212. It's an AND statement. Both pieces have to be true. So I'm going to skip the third one here and jump into our definition. So AND compound inequalities look like this. We want to say that X has to be greater than -1 and X has to be less than 2. So very commonly, we write them as kind of one long phrase here, but you can also write the word written with the word and. So it look like this, -1 has to be less than X, and X has to be less than 2. The other type that we have is OR. So in this one, I just say that -3 has to be greater than or equal to X, or X has to be greater than 2. So one of the ways that I help myself remember which graph is which graph is I think about when I see the word or, I think about somebody rowing a boat here. So of course they've got super long arms to be able to hold on to their oars, but there they are rowing their boat. It's kind of that rowboat or compound inequality. Let's take a look at the next examples. So here we go on the second page here. So we're going to write the inequality for this graph. So let's start off by just writing this. So I like to write each part and then kind of combine them at the end here. So on this side here, on my left side, I've got that my X should be less than, it should be smaller than 4. Then I just have to decide, is this an open dot or a closed dot? If it's an open dot, then I do not put the line. If it's a closed dot, then I do put that line to say less than or equal to. So X should be smaller than 4. And there's that. Let's go to the other side. Here, X should be greater than 9 because it's the sides that are bigger. But this is a closed dot, so I need to say greater than or equal to. It also includes 9. So when I look at this here, I see this is my rowboat oars. I could have a person sitting in the middle of this here, and they'd be doing their rowing. So I know this is going to be x is less than 4 or x is greater than or equal to 9. So this is an or statement. My next one, I'm going to take a look at this here, and I'm just going to do the two endpoints first. So I'm going to say x needs to be greater than or equal to, because it's a closed dot, -7. And then on the other side, I'd say x needs to be less than -1. Now this is an and statement because I do kind of have that because it's not the rowboat look. So I know I can combine these all into one. So I'm just going to put an x in the middle, and then I'll put my two signs. And I know that this one, x needs to be bigger than or equal to. So I'm going to put that. That's -7. And on the other side, x needs to be less than -1. There is my solution there. Again, you can write this as just these two things and then put the word and. I just kind of like to do it in this form here. All right, so let's go to our next part here over to the right. Numbers less than 0 or greater than 3. So numbers that are less than 0 or greater than 3. It says pick two values that satisfy the above statement. So I'm looking for numbers that are less than 0 or greater than 3. So I'm just going to put those two numbers on the number line here, 0, 1, 0, 1, 2, 3. So any numbers that are less than 0, well, anything less than 0, I might say something like -1. And then it says numbers that are greater than 3, well, that could be anything like 4. It says graph situation, so numbers less than 0, so I'd be going to the left down towards the negatives, or numbers that are greater than 3. So that'd be going to the right. It'd be numbers bigger than 3, but both do not include those. So we graph that. Writing the inequality, this is an or statement, again, because it's kind of those rowboat ors. So I'm going to say x should be less than 0, or x should be greater than 3. And then two values that don't satisfy it, well, obviously you'd say something like 1 or 2, because 1 is not less than 0 or greater than 1, and 2 is the same way. Let's go down to our next one here. So next situation says numbers that are greater than -4 and less than or equal to -1. So let's again draw our number line here. So -4, not -5, -4, -3, -2, -1, 0, 1, 2, 3, and so on and so forth. So it says this, pick two values that satisfy this statement. So numbers that are greater than -4. Well, bigger than -4, that'd be something like -3. Less than or equal to -1. So if it's got to be smaller than -1, something like -2 would be a great number there. So graph the situation. So greater than 4, be these numbers bigger than it. Less than or equal to -1. So it's got to be a closed dot above -1. But it's going to connect up with our other dot there to make one long string, which I'm going to just redraw here without the arrows. So I've graphed it. It says write the inequality. Well, that would then be my and statement. So I'm going to pull down this. This should be an open dot. So I'm going to put just the less than sign. And this is a closed dot, so I want to put the less than or equal to. So here I'm going to say it's less than -4, but x should be, or let's see here, x should be greater than -4, and x should be less than or equal to -1. Two values that don't satisfy, -5, +2, anything like that. Bunch of different options there. We got just a couple more here. So let's see this. So now we're given the situation and we need to graph it. So now I'm trying to graph between -6 and 2. So it looks like I'll probably have to do a little bit of skip counting here, but maybe not. Let's see. So -6. If I do a little skip counting here, just counting by 2s, looks like I can get all of the points on there. So my first one, this is a closed dot because it's got the line underneath. So I'm going to put a closed dot at 6. And I'm going to put an open dot at 2. And then it's just saying, okay, G should be greater than 6, so it should be going this way to the right of it. But it should be less than 2, so this is going to be an and statement that they're going to connect up like that. So one solution to this on part B here might be something like -2.2. Could totally be a decimal, could totally be a fraction. We could say something like negative pi if we wanted to go with a crazy irrational, or your basic numbers like -4, 0, all that type of stuff. List one value that's not a solution. Well, it's anything that's not in between -6 and 2. So something like 1,000 would definitely not be a solution. Something like 3 would not be a solution as well. Let's take a look at our very last one here. Graph the situation. So we'll start here. M should be less than -2. So let's just start at -2, -1, 0, 1, 2, 3, 4, 5, and 6. So -2, it should be less than -2. So that means it should be going to the left of it, getting smaller than -2. Again, if you ever get stuck on which direction to put things, just plug in a number and see what happens. If you were to plug in -1 here, well, -1 is definitely not smaller than -2, so it needs to go the other way. If you were to plug in -3 and test it, well, -3 is definitely smaller than -2, so you can put that boundary point in and test it. Let's put this next boundary point in. So M should be greater than or equal to 3. So I'm going to put that boundary point there. And again, doing our test, saying, okay, if I tried the number 2. Well, 2 is definitely not bigger than 3, so it needs to go the other way. And if I tried another number like 4, 4 is definitely greater than 3, so that definitely works. Okay, so we've done that. Let's list one solution. Well, could be a whole bunch of different things. Anything less than -2, something like -3, something like +5, all that stuff would definitely work. List one value that's not a solution. It'd be something like 0 or 1 or 2, something like that would all not work. So remember on or statements like this, it does not mean that both of these things have to be true. It just means that one of the two of these, this or this. It's like if I'm saying I'm trying to decide between, if I'm going to have dinner, I'm trying to decide between burger or pizza. Well, that doesn't mean I have to have a burger and a pizza. It means I'm choosing one of the two things. So that's everything that I've got for you today. Have a good rest of your day.